Well, we're back, and I promised to make the rest of this video about your homework number 3, give you guys something to study for, and I promise you your test is going to look very similar to this. So let's go ahead and finish up. Now, I did a lot of these problems in class and to try to help some folks out and stuff, but I wanted to go through and make a secondary video for every problem that we did. So, you guys didn't need help on a lot of them, but I just want to make sure that you guys had a chance to watch every question and understand what the question is and how to get the answer and stuff. So let's go ahead and get started on your homework, and let's answer all the rest of the problems that we didn't get to in class. It says this: using the leading coefficient test to determine the end behavior. Now, the end behavior was this. Remember, you have if the degree is even versus the degree is odd. And then you got the leading coefficient positive versus the leading coefficient negative. And this was the pattern of the end behavior here. So if the leading coefficient is positive and the degree was even, x to the 4, x to the 6, whatever, it's going to rise on the left and rise on the right. It'll be up and up. However, if the leading coefficient is positive and the degree is odd, it'll fall on the left and rise on the right. But when your leading coefficient is negative, it kind of flips your graph upside down, reflects it across the x-axis, and therefore when you have a degree that is even and a leading coefficient that is negative, it would be fall on the left and fall on the right. And the last thing, if the degree was odd and the leading coefficient was negative, it would rise on the left and fall on the right. So in this particular problem here, we have the degree of our polynomial is 4, and the leading coefficient is equal to 3, which is positive. So we have an even degree and a positive leading coefficient. So even and positive means it's going to rise on the left and rise on the right. So that means the answer is rises on the left, rises on the right. The answer is A. On this next problem, we're supposed to determine whether the graph crosses or touches at each x-intercept. Now remember, you have your 0, and it's focused on the multiplicity. Now, remember this: if your multiplicity is odd, that means you have a power that is odd on your 0 factor, then it is going to cross. However, if the multiplicity is even, it's just going to touch. Whether it's a degree 2 or degree 4, whatever even multiplicity factor to the even power, it's going to make a little parabola. Instead of cross over, it'll actually make a little parabola there. So let's take a look at the zeros on this thing. So I would set this function equal to 0, and then I would set each factor equal to 0. So I have x minus 1 equals 0 and x plus 2 equals 0, making x equals 1 and x equals negative 2. So I have a 0 of 1 and a 0 of negative 2. Now, what about the multiplicity? Well, the 0 of 1 came from the factor x minus 1, and it's being squared. That squared is the multiplicity. So the multiplicity for the 0 guy is 2, and the negative 2 0 came from the factor x plus 2, and x plus 2 has a multiplicity or power of 3. The multiplicity on the 0, on the 0 being equal to 1, has a multiplicity 2, which is even. So with an even, at x equals 1, it's just going to, quote, touch. It's just going to make a little parabola there. Okay. However, at the 0, negative 2, we have a multiplicity 3, which is going to cross there, because this is an odd multiplicity. So it's going to cross. And because it's cubic, it's going to make a little squiggly cubic little graph right there at negative 2. So this one's going to, because the multiplicity 2, it makes a little parabola. This is a multiplicity 3, makes a little squiggle like a cubic graph. But most important, at x equals 1, it touches, and x equals negative 2, it crosses. And that's answer B. Crosses at negative 2 and touches at x equals 1. The answer is B. So on this particular graph, we're trying to kind of figure out which one of these polynomials down here would actually be the graph of this guy. Well, this one, you'll notice that we have zeros at A and at B. So A and B are my zeros, my x-intercepts. But what about their multiplicities? Well, at A, we're making a little parabola on that guy. So it's just touching. Because it is touching, touches, it has to have an even multiplicity. It could be a 2 or a 4 or a 6 power or something like that. However, at B, it crosses, so we have to have an odd multiplicity here. And because it looks like it cuts straight through, it could be an odd being a degree 1, or it could be a degree 3, and we just can't see it squiggle, or degree 5, or multiplicity, whatever. It's got to be an odd multiplicity here. So, now, what were the factors? If A is a factor, if A is a 0, the factor is x minus A. If B is a 0, the factor is x minus B. So I have to have x minus B to an even power, x minus A. You're going to do this again. X minus A to an even power, and the factor x minus B to an odd power. Because it touches here, that's got to be even. It crosses here, it's got to be odd. But the one thing that you notice here, if I take even plus odd, the multiplicities, when you add up the multiplicities, that gives you the degree of the polynomial. Even plus odd, when you take an even number and add it to an odd number, that gives you an odd number. So I happen to have an odd degree. But you'll notice that I'm going up on the left and down on the right, which tells me that's kind of backwards for a traditional odd degree. So my leading coefficient has to be negative. So I've got to figure out the one that's going to have a leading coefficient negative. And how you're going to get that negative is what they did. It looks like that they switched these guys around, because if you switch around something to an odd power, instead of x minus b, you got b minus x to an odd, that actually makes it an odd degree, because if I switch it around, and that would mean I have to take out a negative 1. Negative 1 times, this will be an x plus b if you factor that out, raised to an odd power. Okay, but you can we can rewrite negative x plus b as negative 1 times b minus x raised to an odd power. Okay, and because of that, and take negative 1 and raise it to the odd power, that's going to be negative, which tells me that's going to have a negative leading coefficient. So I believe the answer on this one would have to be D. X minus a squared, because I had a had to have the even multiplicity. So clearly B would not be the answer, because that's an odd multiplicity, and E would not be the odd multiplicity. But if you look at the other ones, the multiplicities on the B term, x minus b or b minus x, has to be odd. That's an even, so A is out. That's an odd, well, B's out. This one is odd, so this is a possibility. And that's it. So the only two choices you got has got to be either C or D. But because the leading coefficient had to be negative, I needed the B minus X factor in there. That's a degree 1 odd. So the D is clearly the right answer. So looking at our next problem, which of the following polynomial functions might have the graph shown? So it's kind of very similar to what we just did. So I notice that I have a 0 at negative 1, and I got a 0 or an x-intercept or a root at 0. In terms of the multiplicities, because I just touch a negative 1, that's got to be an even multiplicity. As something squared or something to the 4th power. And because I cut right through the 0, that's got to have an odd multiplicity. Also, if C is the 0, the factor is x minus C. So the factor would be x minus negative 1, which makes it x plus 1 is the factor for the negative 1, and for 0 it would be x minus 0, or just plain old x. So I've got a factor of x, and I've got a factor of x plus 1. Now the factor with the negative 1, the one factor x plus 1, has to have an even power. The x has to have an odd power. But, and again, the same idea here, when you add up the multiplicities, you get the degree. Since the degree of this guy, even a number plus an odd number, 2 plus 3 is 5, that gives an odd number. So when the degree is odd, and I notice my graph goes down on the left and up on the right, that means my leading coefficient has to be positive. And so I don't want a negative out in front of this guy, so B and D are completely out. X has got to be an odd power, and x plus 1 has to have an even power for the multiplicity, and the only one that does that is E. So the answer is E. Okay. Now, find the remainder when this polynomial is divided by x plus 1. Now this is a great problem because it uses what we call the remainder theorem. And on the remainder theorem, you got two options. If I have x minus c being divided into polynomial f of x, then I would use synthetic division of the c. So remember, x minus c, so pretty much set it equal to 0. You take the opposite number you see. If it's x minus 1, you take 1. So x minus c, you actually take the c, the opposite number, and divide it into the coefficients of f of x. And when you do the synthetic division, the remainder down here is actually equal to f of you plugging c into the problem. So on this particular problem, I've got two options to figure out what the remainder is on this guy. I could actually do the synthetic division. I can say if I got x plus 1, then my c value is going to be negative 1. I'm going to divide into the coefficients of my polynomial. This is x cubed minus 2x plus 1, but my coefficients are 1. But you'll notice there's a no x squared term. We're skipping a term there. You've got to put a 0 in for that. You've got negative 2, and you've got 1. So doing synthetic division, but if there's ever a term missing, I put 0 in for it. Skip a line, draw a line, bring down the first guy, 1, multiply, negative 1 times 1 is negative 1, add, 0 plus negative 1 is negative 1, multiply, negative 1 times negative 1 is positive 1, add, negative 2 plus 1 is negative 1, multiply, negative 1 times negative 1 is positive 1, add, I get 2, and the last number we block off, this is the remainder. So my remainder is 2. So the answer is C on this problem. Or another way I could have done this, if the synthetic division is too bad, is just do this. Take f of your c value. Our c value is negative 1. And that would be negative 1 cubed minus 2 times negative 1 plus 1. Let's crunch some numbers. Negative 1 cubed, negative 1 times negative 1 times negative 1 is negative 1. Negative 2 times negative 1 is a plus 2. And plus 1. Negative 1 plus 2 is 1, plus 1 is 2. And that probably would have been the easier way to do this problem, and actually the way we really wanted you to do it, but this one was a small polynomial. Maybe on the test I'll give you a big polynomial to do this one or whatever. The next problem we actually did in class, so you can refer to the first video on this stuff that people had questions about, because this particular problem you're looking for all the zeros. They give you 1, so you use synthetic division on your polynomial with that particular c value because they gave you the 0. Then you do long division, and you'll notice when you divide it out, you should get a remainder of 0 if it's a factor, or a 0, and then, or a root. And then you got the remaining, or the quotient down here, which is 1, negative 4, negative 1. That gives you x squared minus 4x minus 1, and that's a quadratic. And when you set it equal to 0 to solve, you had to use the quadratic formula, but it gives you the other two zeros. And they are going to be, like I said, conjugate pairs because it didn't factor. All right, number 7. Which of the following is not a potential rational zero. This is that rational zero theorem, or rational root theorem, where we do the p's over the q's. So if you remember, the p's come from the a0, which is your constant term. So look at your polynomial, and what is the constant term? It's 1. The p's are all the factors of 1. What are the factors of 1? Plus or minus 1. The an is called the leading coefficient, and the leading coefficient on this polynomial, it goes with the degree term. Degree is 4, but the leading coefficient is 6. And q are the factors of an, the 6. What are the numbers that factor 6? Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So the rational root theorem states that if I can, any way I can take a p divided by q are the potential rational zeros. So my potential rational zeros are 1 divided by 1, which is 1, plus or minus 1. 1 divided by 2, which is 1/2, officially plus or minus. I'll just leave the big plus or minus out front for all these guys. The next one would be 1 divided by 3, so it's plus or minus 1 over 3. The next one's going to be 1 over 6, so plus or minus 1 over 6. So it's plus or minus literally each one of these guys. 1, 1/2, 1/3, and 1/4. So 1, 2, 3, 4 times 2 for the plus or minus. It's actually 8 potential rational zeros, possible rational zeros. The fact is this polynomial has at most 4 of them. So these are the list of the rational zeros we can get now. The question is, which one of these guys in my answer set is not one of my rational zeros? 1 is there, -1 is there, 1/3 is there, -1/2 is there, but 3 is not in my lineup. So the one that is not a potential rational zero is 3. Find the roots, zeros of this polynomial and add them together. Now, to do a problem like this, when you're actually trying to find the roots of a polynomial, you got an ace in the hole with your calculator, because you just have to know the word root, 0 means the same thing as an x-intercept. So if they're asking me to find roots or something or other, the first thing I'm going to do is graph this guy. So let me go over here to my equations and clear out any kind of stuff that I had in there before. And I'm going to graph this function. It's x to the 4th minus 2x cubed minus x squared plus 2x. I'm going to hit a zoom standard. Zoom standard gives me a -10 by 10, -10 by 10 screen. And here is my graph. And I can, if I need to, zoom in on these guys to see what they are. And as I zoom in, I see this. -1, 0, 1, and 2. We seem to hit these zeros. The graph comes in, comes down, and cuts up, goes over, and cuts up again. So my zeros of this particular polynomial are clearly -1, 0, 1, and 2. But they made you, instead of doing the calculator, jump through one more hoop. You were supposed to add the zeros together. So to get your answer for this problem, you take -1 plus 0 plus 1 plus 2. -1 plus 0 is -1 plus 1 is back to 0 plus 2 is 2. So we add them together, you get the answer C, 2. Next problem, you're supposed to find the vertical and horizontal asymptotes. Okay, so the first thing you want to do to the original polynomial, if you're looking for the vertical asymptotes, is to factor it. So I've got x minus 1 divided by, in the denominator, I've got x squared minus 2x. I can factor an x out, and I'm left with x minus 2. I don't see any terms canceling, because if it did, it doesn't create a vertical asymptote. It creates holes in the graph. Remind you of that when terms in the denominator cancel. But nothing cancels here. So to find a vertical asymptote, you set the denominator, which is x times x minus 2, equal to 0. And when you factor it, you set each factor equal to 0. X equals 0, x minus 2 equals 0. Solving for x equals 0, and x equals 2 when you add 2 to both sides. So these are my vertical asymptotes. To get the horizontal asymptote, it was a theorem about the degree of the top versus the degree of the bottom. Remember, if the degree of the top is less than the degree of the bottom, y equals 0 is the horizontal asymptote. When the degree of the top equals the degree of the bottom, is the y equals the ratio of the leading coefficients is the horizontal asymptote. And when the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. So on this particular problem, we'll go back to the original function. The degree of the numerator is 1. The degree of the top is 1. The degree of the denominator is 2. And we have that the degree of the top is less than the degree of the bottom. According to our theorem, then y equals 0 is the horizontal asymptote. So I've got vertical asymptotes x equals 0, x equals 2, and the horizontal asymptote is y equals 0, which makes D the answer. In this one, find the horizontal asymptote if any of this function. Again, with the horizontal asymptote, you've got to do the degree of the top, numerator, versus the degree of the bottom, the denominator. The degree of the numerator, the degree is the highest power on the x's. This is x to the first, so it's 1. The degree of the denominator, this is, again, x to the first, which is 1. When the degree of the top is equal to the degree of the bottom, then, according to your horizontal asymptote theorem, y is equal to the ratio of the leading coefficients. So y equals, now we've got to look at my numerator polynomial. The leading coefficient attached to the degree term is a 2. Over the leading coefficient is happens to be attached to the x to the first, which is understood to be a 1. So my horizontal asymptote is y equals 2 over 1, which is 2. Y equals 2. The answer is A. On problem number 11, again, doing the horizontal asymptote, so I've kind of got one of each different kind. When you're doing the horizontal asymptote, we do the horizontal asymptote theorem, and we focus on the degree of the top, the numerator, versus the degree of the bottom, the denominator. The degree of the top, that's an x cubed, so the degree is 3. The degree of the bottom, the denominator, that's an x squared polynomial, so that's 2. Here, the degree of the top is greater than the degree of the bottom. And according to the horizontal asymptote theorem, when the degree of the top is greater than the degree of the bottom, then there is no horizontal asymptote. So the answer for this problem would be E, no horizontal asymptote. The next problem, find the vertical asymptote, if any, of the function f of x equals x plus 2 divided by x squared minus 4. Now remember, the first thing you need to do to a polynomial before you figure out the vertical asymptotes is make sure you factor the numerator and the denominator. Well, numerator is just pretty much x plus 2. Can't really factor anything out of that guy. But the denominator is x squared minus 4. That's a difference of squares, so that factors into x plus 2 times x minus 2. And here, x plus 2 divided by x minus 2, the x minus 2's would end up canceling. So the factor x plus 2, the one that cancels, actually is not a vertical asymptote. That's where the hole in graph comes from. It comes with the factor x plus 2. So the vertical asymptote comes with the remaining factor in the denominator, which is x minus 2. So to find the vertical asymptote, you set it equal to 0 and solve, and you get x equals 2. Just to let you know, to get the hole in the graph, you set the factor that canceled with the numerator denominator, you set that equal to 0 and solve. You actually have a hole in the graph, not a vertical asymptote. There's a hole in the graph where x is equal to 2. So the only vertical asymptote is x equals 2, which is answer D. This is one of the problems that we did in class that a lot of students had some questions over, and this is a great problem to study because you basically are now solving rational inequalities. Any kind of inequality, you've got to do the number line test too, but you first got to set it equal to 0. So on this problem, I subtracted 1, So I have 2 minus 1, which is 1, plus x over x minus 1. But when you have fractions, I've got to get a common denominator. So 1 over 1, and I got my common denominator, or only denominator is x minus 1, so I made that 1 times x minus 1 on top, x minus 1 on the bottom. So I got x minus 1 over x minus 1 plus x over x minus 1. You write it as one big common denominator, x minus 1 with the x minus 1 plus x in the numerator. Combined like terms, x plus x is 2x, so I cleaned it up to one big fraction, 2x minus 1 over x minus 1, and that is still less than or equal to 0 once I pulled everything to one side, which means I'm looking for the negatives, but I've also got equal to 0. So I got to find my zeros first. So I set my rational equation equal to 0. I multiply both sides by the denominator, and that just sets the numerator, 2x minus 1 equals 0, and I get x equals a half. Because there's an equal to on your inequality, we want 1/2 to be in our solution set. So I put a little filled in dot to remind myself to include that point. The other thing I got to find, because I have a fractional or rational inequality, is I got to find where the function doesn't exist at. So 2x minus 1 over x minus 1, it doesn't exist when the denominator, x minus 1 equals 0. When solving for x, I get x equals 1. So I got over here at 1, but I got to put an open circle because I've got to omit that problem from my solution set. And then I set up my number line, 1/2 with the filled in dot because that's where it was equal to, and I won't be equal to in my answer. The 1 is my vertical asymptote. I always got to put open circles on that guy. And then I did test values. A number less than 1/2 would be 0. I plug 0 into my rational function, and I end up getting 1. Don't care what the number is, but the sign is positive, which means I get positive numbers there. I pick a number between 1/2 and 1. My students chose 0.6. Great, but I plugged in 0.6 on this thing. I got negative a half, so it's negative there. And so a number greater than 1, I chose 2. I chose to plug 2 into my function, 2x minus 1 over x minus 1. When I plug 2 into it, I got 3, which is positive, so everything is positive. Then I look for my inequality. I want less than or equal to 0. I want the negatives. So I shade my negatives, and that's between including negative 1/2 to 1, not including the 1. So negative inclusive, bracket 1/2, comma, 1, parentheses. So the answer is clearly A. Here's another inequality here. So I'm going to do it the same way, but this one I didn't have to work so much algebra on the common denominator fractions. They went ahead and were nice enough to actually factor it for me. So I have x plus 4 times x plus 2 times x minus 6 is a less than 0. First thing I'm going to do is find my zeros, so I'm going to take x plus 4 times x plus 2 times x minus 6 and set it equal to 0. Then I'm going to set each factor equal to 0, which gives me pretty much x equals negative 4, x equals negative 2, and x equals positive 6. It's by setting each factor equal to 0. So these are my zeros. The question is, do I want my zeros in my answer? If you look at this inequality, it doesn't have equal to on it. So each one of these guys I do not want in my answer, so I'm going to use little open circles on this thing. And I'm going to draw my number line, because this is an inequality, so I have to find regions of answers. So anytime I'm doing in number lines, inequalities, I want to do number lines on it. But I want to put these numbers in order. So the smallest number would be negative 4. The next number would be negative 2, and the biggest number would be positive 6. And they all got open circles, so we are not including these guys in our answer. And because of that, I can go ahead and start marking out answer C and D cannot be the answer because they're trying to include these endpoints. I do not include the endpoints because that is a strict less than. Now I'm going to do test values. So I'm going to pick a number in my interval less than negative 4. I choose negative 5. And I'm going to plug it into my function. Again, my function that I'm plugging it into is this x plus 4 times x plus 2 times x minus 6. So when I plug in negative 5 into this thing, negative 5 plus 4 is negative 1. Negative 5 plus 2 is negative 3. Negative 5 plus 6 is a negative 11. When I multiply it out, I get a negative 33. I don't care what the number is. It's negative there. Pick a number between negative 4 and negative 2. I obviously would choose negative 3. Plugging negative 3 into my function. Negative 3 plus 4 is 1. Negative 3 plus 2 is negative 1. Negative 3 minus 6 is negative 9. Negative 1 times negative 9 is positive 9 times 1 is positive 9, but it's positive. So everybody in that interval is positive. Pick a number, use your brain between negative 2 and 6. I choose 0. Plugging in 0 in this thing, that's 4 times 2 times negative 6. 4 times 2 times negative 6, that's 8 times negative 6, which is negative 48, but it's negative, so everything is negative in that interval. And picking a number bigger than 6, I choose 7. Plugging in 7 into my polynomial, 7 plus 4 is 11. 7 plus 2 is 9. 7 minus 6 is 1. 1 times 9 times 11 is 99, but it's positive. And now I'm going to look at my interval, my inequality, and try to figure out what kind I want. Since this function was set less than 0, we want the negative guys. So it's negative between negative infinity up to negative 4. It's also negative between negative 2 and 6. They didn't use interval notation on this one. They use a set notation. So to read my number line in set notation, this would be x's that are less than negative 4, because we don't want to be equal to negative 4. Or it'll be negative 2 is less than x, which will be less than 6. The x's will be between negative 2 and 6, and which makes my answer B. Again, here's another inequality, so I'm going to do the same thing, but this one, they weren't so nice to me. They didn't factor it. The first thing I do to any kind of inequality that's quadratic or rational or whatever is I got to set it to 0. So the first thing I'm going to do is I'm going to subtract 6 from both sides, and that gives me x squared minus x minus 6 is less than or equal to 0. This thing factors. This factors into x minus 3 times x plus 2 is less than or equal to 0. The next thing I'm going to do is I'm going to figure out where it's equal to 0. So x minus 3 times x plus 2 equals 0. I set each factor. X minus 3 equals 0 and x plus 2 equals 0. Gives me x equals 3 and x equals negative 2. The question is, do I want these zeros in my solution set? But because the inequality has an equal to, we want the less than or equal to. Because they're equal to, I'm going to use filled in dots. I'm going to use these guys. That'll be equal to on these answers. Okay. The next thing I'm going to do is I'm going to draw my number line, where my function is this x squared minus x minus 6 number. I'm going to put these numbers in order. Negative 2 is the smallest because it's negative, and positive 3. So positive 3 is on the right, negative 2 is on the left, and I'm going to put little filled in dots to remind me to include these guys. Now I'm going to pick test values for my function. A number less than negative 2 would be negative 3. When I plug negative 3 in this thing, negative 3 squared is 9. Minus negative 3, 9 minus negative is positive. 9 plus 3 is 12. Minus 6 is 6. Don't care what the number is, it's a positive number. So everybody in the interval is positive. Picking a number between negative 2 and 3, obviously I would use my brain and use 0. And plugging in 0 in this thing is real simple. I get negative 6, so it's negative, so everything is negative. Pick a number bigger than 3, I choose 4. Plugging a 4 in this thing, 4 squared is 16, minus 4 is 12, minus 6 is back to 6 again, but it's positive. But now I go back and look at the inequality, and I want less than or equal to, which means I want the negatives. These are the guys that I want. So my answer is bracket negative 2 to 3, but once again they did it in set notation, which means negative 2 is less than or equal to, because I'm going to include these points, x, which is less than or equal to 3. Because of that equal to, I can already go admit D is not an answer, B is not an answer. But you'll see that the only answer here is C. So B and D can't be the answers because they don't have the equal to on them. No, so. Okay. This one is a systems of equations, a classic chapter 8.1 stuff here. So I want to solve this system of equations. But if these guys are everything's set to one side, so I basically have this. Negative x minus 2y equals 8, and 2x minus 2y equals negative 3. since my variables line up, and I could use either elimination or substitution because the directions don't say, it just says solve. I like elimination method when they line up. And I'm going to eliminate one of the variables, and I'm going to eliminate the x's. So I'm going to take that top equation and multiply by 2, because to eliminate a variable, I want to have equal but opposite coefficients. And remember, what I do to one side of an equation, I do to the other. It makes it a nice equal math move. I'm going to distribute this 2. That's going to give me a negative 2x. 2 times a negative 2 is a negative 4y, equals 2 times 8 is 16. You got to do it on both sides of the equation. And on my other equation we didn't touch, which is 2x minus 2y equals negative 3. And you see here that my x's are the same coefficients except opposite signs. So when I add my equations together, the x's cancel each other out. I've got minus 4y minus 2y, which makes it negative 6y, equals 16 minus 3 is 13. So when I divide, I get y is equal to 13 divided by negative 6, or negative 13/6. Oh yeah, they did fractions on this one. But I got my y number as negative 13/6. So it's either got to be A or B. That's the only one that has a negative 13/6. So 50-50 shot now. So to figure out what the x is, I'm going to go back to one of my original equations. I'm going to go back to the top equation, smaller coefficients. Negative x minus 2y equals 8. But I know what x is. I know what y is. Y is negative 13/6. So when I substitute it in, I get negative x minus 2 times negative 13 over 6 is equal to 8. Solving for x, I clean it up. This is negative x. A negative times a negative is a positive. 2 goes in the 6 3 times. Let's go ahead and reduce the fraction. 2 goes in the 6 3 times, so that becomes a plus 13 thirds equals 8. I'm going to subtract 13 thirds from both sides and use my calculator because these are all 4 fractions. So I get negative x is equal to, grabbing my calculator here, turning it on and clearing it out. This will be 8 minus 13 divided, 8 minus 13 divided by 3. And hitting the old math fraction button, converting it to a fraction to make it nice for me, I got 11 thirds. But negative x equals 11 thirds. So I'm going to divide by negative 1 on both sides. That's going to give me x is equal to negative 11 thirds. So, and we traditionally write our answer in ordered pair format, x, y. My x is negative 11 thirds. And my y is negative 13 thirds. I'm sorry, 13/6. 13/6. So I'm looking for negative 11 thirds and negative 13/6, which is the answer A. So A is the answer. Now we did this problem also in class, so I'm going to take a look at this guy for a second. The solution to the equation 10 raised to 3x equals 5. Okay. Now if I look at these guys, we've got natural log answers and we got common log answers. Well, traditionally, I'm going to have to do it both ways because I got both sets of answers. But if I was doing this problem and I got a base 10, I got a button on my calculator that does base 10, and that's called the log base 10. So if I was doing this problem, because it does not have an e in the problem, I typically wouldn't use natural logs. But I could, but you know, it's not really going to help me out. I would use the common log because we have a property that is that the log of 10 raised to the x would be just x, because the log on a common log is understood even though we don't write it as base 10. So I've got this equation where the variable is in the exponent. There's only one thing in the universe that brings down exponents, that's logs. And because I have a base 10, I'm going to use the common log. I'm going to take the log, understood to be base 10, of 10 to the 3x is equal to the log of 5. What I do to one side, I do to the other. According to our log properties number 3, exponents get to pop out front. So I get 3x times the log of 10 is equal to the log of 5. And if I wanted to solve for x, we're multiplying x by 10 and x by log 10. But wait a minute. What is the log of 10? Well, the log, which is understood to be base 10, of 10 is they end up canceling and get the power. The power on that 10 is understood to be a 1. So they'll end up canceling, you get 1. So log of 10 is equal to 1. And if you don't believe me on that, you can also, because we have that log button on the calculator, I hit log, L-O-G of 10, and it's equal to 1, because it's the log base 10 of 10 raised to a power. Log base 10 and 10 will cancel, and you get the power that's understood to be a power of 1. So I'm left with this. 3x equals log 5. I would divide by 3 on both sides, and I get the answer x is equal to the log of 5 over 3. And the log of 5 over 3, and that's understood to be a base 10 log. The log of 5 over 3 would be answer is D. Just to show you that it is not one of these two guys that use the natural log answer, if I have 10 raised to the 3x equals 5, I can take the natural log of both sides. Exponents pop out front, so that's 3x times the natural log of 10 is equal to the natural log of 5, because it's a log base e, but there's no e's in the problem, so the natural logs don't cancel. Solving for x, I'm multiplying by 3 and multiplying by log 10, natural log 10. So to get rid of multiplication, I'm going to divide by 3 and divide by the natural log of 10 on both sides. This cancels here. I get x is equal to the natural log of 5 over 3 natural log of 10. This is also an answer, but not one of my answers. They wrote natural log of 10 over 3 natural log of 5. Well, they tried to flip it up here, but that's not what I got here. So these two guys are not even in the answer set, because this is what it would be if I did natural logs. But this is really what they wanted, and you really should have used a common log, because you got a base 10 on this thing. Here's another exponential equation. 3 raised to the x equals 1/9. But this is something special, because this is not, I could use logs if you want to, but it's a lot easier than that, because this is a base 3 raised to the x, and I can write 9 as a base 3. 9 is 3 squared. So this is 3 to the x is equal to 1 over 3 squared. But this 3 is in the numerator, this 3 is in the denominator, but I can bring a denominator up to the numerator, but I have to make my exponents negative. Remember your exponential properties. When you bring something from the bottom to the top, you have to make the exponent negative. So this will imply 3 to the x would be equal to 3 to the negative 2, and this is one of our algebraic properties. If we got an equation that's equal and the bases are equal, that will imply that the exponents, the x has to be equal to negative 2. So the answer is x is negative 2. The answer is A. All right, and again, these are some formulas that we expect you guys to have memorized. Find the accumulated value for an investment of $1,500 invested at 14% interest, compounded quarterly for 2 years. You know, there's 2 formulas you need to have memorized in terms of compounding. It is the A equals P times 1 plus R over N raised to the NT, and A is equal to PERT. These are my 2 compound interest formulas. This A equals P times 1 plus R over N raised to the NT is called regular compound, and we only use this formula, A equals PERT, for the word compounded continuously. So, find the accumulated value, that's find A basically, for an investment of $1,500, so that's my principal, that's how much I'm investing, $1,500, at 14% interest. Remember, percentages for people who can't do math. 14% is 0.14. Compounded quarterly. If you compound quarterly, how many times a year is that? 4 years. For time is equal to 2. Plugging into the regular compound, because I didn't see the word compounded continuously in here, it's compounded quarterly, that's your regular compound. A is going to be equal to 1,500 times 1 plus 0.14 divided by 4 raised to the 4 times time is 2. So I'm going to use my calculator on this one, because remember we were trying to find A, the accumulated value here. So let me clear that thing out so you guys can see this. 1,500 times 1 plus 0.14 divided by 4 raised to the 4 times 2. And if you got the old style calculator, don't forget to put parentheses around the exponent. And then what do I get? I get $1,975.21, which is clearly answer D. A similar problem here is this. Jerry plans to buy a used car for $18,000 in 5 years. How much money should you invest now at 5%? Let me blow this up, you guys can see this a little better. 5%. Compounded continuously. There it is right there. Compounded continuously. So at the end of 5 years, he would have $18,000. Okay? So, to invest now, how much should he invest now? Invest now is the principal. So we're actually looking for the principal, where in the future, he wants the accumulated value of $18,000. How much should he invest now to get $18,000? In time equals 5 years at an interest rate of 5%, which is clearly 0.05. But compounded continuously is my PERT formula. So A is $18,000 equals P, what we're looking for, times E, that 2.718 number raised to the R, 0.05 times time, which is 5. We can clean that up. This will be 18,000 equals PE to the 0.05 times 5 would be 0.25. But E to the 0.25 is nothing but a number. And if I have 18,000 equals P times a number, I would divide by the number, divide by E to the 0.25, and solve for P. So P would be equal to, and here we go, 18,000 divided by E raised to the 0.25, which I get $14,018.41. That's how much he needs to invest right now, which is 18,000. It looks like B right there. Answer is B. Solve the equation. Log base x of 1/8 equals 3. Anytime you've got a single log equation and you want to figure out, solve for something or other, typically what you want to do here is use what we call the smiley face definition, so you can rewrite the logs. Since y equals the log base a of x, this is equivalent using what I call the smiley face definition, but it's the definition of logs that you start with the base a, raise it to the other side y, it equals what you're taking a log of, x. This is log form, this is exponential form, but they're equivalent to one another. Exponential form and log form of the same equation. So since I have log base x of 1/8 equals 3, I would start with the base, raise it to the other side, that gives me x cubed is equal to what you're taking a log of, 1/8. Now, the mission here is to solve for x. I got x cubed equals 1/8. What gets rid of a cube so I can x by himself? What's the opposite of taking a cube of something or other? Take the cube root. Take the cube root of both sides. This cancels, so x is equal to the cube root of 1/8, which is the same thing as the cube root of 1 divided by the cube root of 8 using my radical properties. And the cube root of 1 is 1, because 1 times 1 times 1 is 1. The cube root of 8, what times what is 8? It's 2. So x has got to be 1/2. See. This is one of those problems of the Humpty Dumpty, as I called it in class problems, where I have a log base 2 of 17 times the square root of x over y, and we want to write it as a sum or difference of logs. Basically, we want to bust this guy up. Remember, multiplication turns into addition, division turns into subtraction. So I've got the log base 2 of 17, but powers get to go out front. I don't like radicals. I want to write them as a power. So square roots are the same thing as x to the 1/2 power over y. In the numerator, you're multiplying. If you have something in the denominator, it means you're going to divide by it. So this would be, as I bust this thing up, the log base 2 of 17, that's multiplication, that turns into addition, plus the log base 2 of x to the 1/2. This is division, so that becomes minus the log base 2 of y. We're almost done, but our third log property says if you got the log of something to a power, powers get to go in front of the logs as you clean it up. So this would be equal to the log base 2 of 17 plus 1/2 the log base 2 of x minus the log base 2 of y, which means my answer is B. Well, this was a long homework set, but I try to give you good problems that if you master this, you'll ace anything I put on the test. Number 23. Write the expression for 2 log x minus 3 log x plus 1 as a single variable. Again, Humpty Dumpty, but this time they want me to put it back together again. But to be able to use my log properties of working backwards, addition turns back into multiplication, subtraction turns back into division, the coefficients in front of the logs have to be a 1. If you've got any number in front of the log, he has to go back where he came from, which is the exponents. So this 2 log of x minus 3 log of x plus 1 would be equal to, powers go back, this would be the log of x squared minus the log of x plus 1 cubed. The powers go back in the exponents. Now this is subtraction, and subtraction turns into division, so it's one big log. And we're using common logs on this thing, so I'm not writing the base, but it's understood to be 10 of a fraction. The positive thing goes on the top. This is understood to be positive, so the x squared is on top. Minus turns into division. Division means the x plus 1 cubed goes in the denominator, x plus 1 cubed. And there's my solution, which is answer E. This is one of the log equations you guys asked me to do in class, so I've already done this one. But first things first. This is a log type 2 equation. I got logs on both sides, and you're supposed to solve for x. So subtraction turned into division because the coefficients in front of the logs are 1. So this is one big log of 5 plus x over x minus 5 equals log of 3. And like I said before, when you have log equations, you've got log of stuff equals log of stuff, you can cancel the logs. This is log type 2. And this is a base 10, so what you're really doing is raising 10 to each side, which ends up canceling your log base 10s. Then that gives you the equation 5 plus x over x minus 5 equals 3. You multiply both sides by your common denominator because you got fractions. You want to get rid of your fractions, so this cancels. You get 5 plus x equals 3 times x minus 5. I distribute. It gives me x plus 5 plus x equals 3x minus 15 when I distributed. Subtract x, add 15, you get 20 is equal to 2x, and then divide by 2x equals 10. But remember, it's a log equation. On every problem on the test and the final exam, when it's a log equation, you got to check your answer. And you're not checking to make sure it's right, you're checking to make sure you're not taking a log of a negative number. So plugging 10 in here, 5 plus 10 is 15, log 15, that's positive, that's fine. 10 minus 5, well that's 5 and that's still positive, so I can plug in 10 into this thing, so it's fine. What is the function g of x obtained by shifting the graph of f of x equals 2 to the x, an exponential graph, 2 to the x, 3 units left and 1 unit down. 3 units left. Now remember your systems of shifting, stretching, and reflecting. If I want to go left, going left, that means I'm going to add 3 inside, or 2 the x's, inside 2 the x terms. And I want to go down 1. Down 1 means I'm going to subtract 1 from the function. So I've got y, or f of x, equals 2 raised to the x, so I'm going to go 3 units left. So my new function would be y is equal to 2 raised to the, if I want to go left 3 units, it means I'm going to add 3 to the x's. And if I want to shift them down, I'm going to subtract 1 from the entire function. I'm going to move the whole function down. So my answer is D. William Gates invested $50,000 in an account that pays 5% yearly interest compounded continuously. I have to tell you what formula. Compounded continuously tells me I'm going to use the PERT formula. He invests $5,000, so that's my principal. $50,000. My principal is $50,000. Paying 5%. 5% mathematically would be 0.05. How long will it take his money to double? How long is a question of time. To double his money, the amount in the account will be, doubling $50,000 is $100,000. So plugging this into my equation, 100,000 is equal to 50,000 e to the 0.05 times t. T is the variable that I want to solve for. That's a question mark right there. I can't read my handwriting. That's my question mark, what I want to find what t is. Well, this is now an exponential equation where the variable is in the exponent. There's only one thing in the universe that brings down exponents, and that's logs. Because there's an e in the problem, I want to use the very special natural log. But before I can use the natural log, I got 50,000 in front of my e. I got to get the e term by himself. So the first move you should make is divide by 50,000. So 100,000 divided by 50,000, well, that's easy. That's just 2, doubling thing here, equals e to the 0.05t. Now I've got the e by himself. I'm going to take the natural log of both sides, and the natural log and e's cancel. That's going to leave you with the natural log of 2 is equal to 0.05t. Solving for t, I would divide by 0.05 on both sides, and I get t is equal to, here it is, the natural log of 2 divided by 0.05. 13.86 when you round it off, years, that's how long it would take, 13.86 years, which is answer B. Looking at some of the free response questions, I grabbed these. A lot of these problems came from old final exams and stuff, so I'm always trying to prepare you guys for final exams. But here it is, one of those leading coefficient things here. So let's take a look at this polynomial. I got h of x being negative 4x to the fifth plus 3x cubed minus 6x squared plus 2x minus 15. All right, what about the end behavior? All right, the degree of this polynomial is equal to 5, which is odd, and the leading coefficient is equal to a negative 4. So we have a negative leading coefficient and an odd 5 degree. So as an odd degree, typically it goes down on the left, up on the right, but because the leading coefficient is negative, it flips it upside down. That means it's going to go up on the left and down on the right, which means it rises on the left and falls on the right. Okay. Well, which means my answer is, let's see here, rises on the left, falls on the right. The answer is D. Okay. On this particular one, we've got 4x to the fourth plus 8x cubed minus 3x squared minus 12x plus 5. My leading coefficient on this problem is 4, which is positive. And my degree on this particular problem is 4, which is even. Even degree, positive leading coefficient means I'm going to rise on the left and rise on the right. So as I rise on the left and rise on the right, that means the answer is, rise left, rise right, that answer is B. Okay. Problem number 2 here. Given this rational function, state the vertical asymptotes and holes, if any, and then state the horizontal asymptote. So as we talked about before, when you want to go for vertical asymptotes or holes, the first thing you want to do to your polynomial is factor it. In the numerator, I can factor out a 3. That gives me 3 times x minus 2. Over my denominator, that's going to factor x squared plus 3x minus 10 is x 10. It's got to be 5 and 2. That differs by 3 there, so it's 5 and 2. Because it's a minus, one's positive, one's negative, and because the middle term is plus, the bigger number is going to be plus, so plus 5 minus 2. And you'll notice once again, here, the x minus 2's would have canceled, which tells me the x minus 2 factor is a hole in the graph. You set it equal to 0 and solve, so you get x equals 2. That's where your hole is going to be at. And the vertical asymptote is the other denominator that doesn't cancel. You say x plus 5, you set that equal to 0, and you get x equals negative 5. So the answer is the vertical asymptote is x equals negative 5. And the hole in the graph occurs at x is equal to 2. What about the horizontal asymptote? Well, the horizontal asymptote, if you notice this guy, the degree of the top is 1. Degree of the bottom is 2, and the degree of the top is less than the degree of the bottom. That will imply that y equals 0 from a horizontal asymptote theorem is the horizontal asymptote. People asked me about this problem in class, so I went ahead and did it for them. I got f of x is equal to 2x cubed minus 11x squared plus 7x minus 6. Use the remainder theorem to find f of 2, so which means I can take 2 and divide into the coefficients of my polynomial, and when I get my remainder, that'll be my functional value. The other way I could have done this was just like this. F of 2 would have been 2 times 2 cubed plus 11, minus 11 times 2 squared plus 7 times 2 minus 6. And plugging that on my calculator, I end up getting negative 20. So you can either plug the number into the function or use synthetic division and get your remainder, whatever becomes easiest for you. On this problem, I did part of it for students in class, and I didn't finish it up, but I'll finish it up for you guys now. They wanted me to do long division on this thing. So I wanted to take x squared plus 3x minus 2, my divisor, and divide it into x to the 4th plus, there's no cube term, so it's 0x cubed plus 3x squared minus 5x plus 3. Okay? I'm going to, what do I need to multiply x squared by to get x to the 4th? That was an x squared, so I multiply and I distribute it. X squared times x squared is x to the 4th. X squared times 3x is 3x squared. And x squared times minus 2 is minus 2x squared. But then I have to subtract, which changes my signs. First term cancels. 0x cubed minus 3x cubed is minus 3x cubed. 3x squared plus 2x squared is 5x squared. I bring down my next victim, minus 5x, and start the game all over again. What times x squared is negative 3x cubed? I need to multiply by negative 3x. Negative 3x times x squared is negative 3x squared. Negative 3x times a positive 3x is a minus 9x squared. And a negative 3x times a negative 2 is a plus 6. But then I have to go and subtract, which changes my signs. So this becomes plus, and this one becomes minus. 3x cubed, negative 3x cubed plus 3x cubed cancels. 5x squared plus 9x squared is 14x squared. Minus 5x minus 6x is minus 11x. And then I bring down my next number, plus 3, and play the game one more time. What times x squared is 14x squared? Plus 14. 14 times x squared is 14x squared. 14 times 3x, 14 times 3 is 42. I better double check on the calculator here. Did that in my head. 14 times 3 is 42, just to let you know. So that becomes 14 times a positive 3, that would be plus 42x. And then 14 times minus 2 is minus 28. Now I've got to subtract, which changes my signs. First term cancels, 14x squared minus 14x squared. I've got negative 11x minus 42x. Minus 11 minus 42 is minus 53x. And 3 plus 28 is plus 31. And that is my remainder because x squared doesn't go into x anymore. So writing this out in terms of the division algorithm, this is the dividend equals the quotient, what you're dividing by. It's going to equals the divisor, that's the divisor, times the quotient. My quotient is x squared minus 3x plus 14. Plus the remainder, and my remainder was this negative 53x plus 31. And so there's the remainder, there's my quotient, and remainder. We're going to do the same thing, but on this problem, because we're dividing by x plus 2, I'm going to do synthetic division. So with synthetic division here, I'm dividing by x plus 2, so my C number is going to be negative 2. Because remember, you look at these as factors. This is x minus C as compared to x plus 2. That implies that C has got to be negative 2. And where it comes from is basically just setting that equal to 0 to figure out your C number. So with these, when you're dividing by x minus C, linear terms, that's when you use synthetic division. The C is always the opposite number that you actually see. I see x plus 2, C is going to be negative 2. I'm going to take negative 2, I'm going to divide it into my coefficients. But you'll notice that there's a term missing. There's no x cubed term. So I got to put a 0 in for it, otherwise this thing doesn't work out. This is a 1, 0, 1x to the 4th, no x cubed, plus 3x squared, minus, sign goes with it, 5x plus 3. Skip a line, draw a line. Bring down your first number, multiply, negative 2 times 1 is negative 2, add 0 minus 2 is minus 2. Multiply, negative 2 times negative 2 is positive 4, add, 3 plus 4 is 7. Multiply, negative 2 times 7 is negative 14. Add, minus 5 minus 14 is negative 19. Multiply, negative 2 times negative 19 is a positive 38. And add, 3 plus 38 is 41. And block off that last term because that is your remainder. But again, we want to actually write this in the form of the division algorithm. And the division algorithm, just like we did here, is your dividend, which is your x to the 4th plus 3x squared minus 5x plus 3. That's equal to your divisor, x plus 2, times the quotient. This is your quotient, but it's just a coefficient. You start from the back. That's the remainder part. So this is your constant term, x, x squared, x cubed. So that would be 1x cubed minus 2x squared plus 7x minus 19 plus the remainder. So here's the quotient part. Here's the remainder, which is just 41. And this is your solution written in the form of the division algorithm. Almost done. Go through this one here. Okay, good practicing. Again, trying to get you guys very prepared for your test. All right, on this particular problem, we're given a polynomial. F of x equals 2x to the 4th plus 6x cubed minus 6x squared minus 22x minus 12. We're supposed to list all possible rational zeros. Well, on this problem, your AN, your leading, your A0, start with A0. Your constant term is negative 12. P are the factors of the constant term, negative 12. That's plus or minus 1, 2, 3, 4, 6. What else divides negative 12? And 12 itself. AN, your leading coefficient, is 2, where the numbers that divide 2 are plus or minus 1 and plus or minus 2. So the list of possible rational zeros is any way I can take a P and divide by a Q. So taking a P and dividing it by Q, here we go. A P over a Q would be all these numbers over 1. So I'll just go ahead and write that over here. P over Q would be plus or minus 1, 2, 3, 4, 6, and 12. Then you got to take all these numbers and divide by 2. That's going to be a 1/2. 2 over 1, which is 2. 3 halves, that's not in my mix. 4 halves, which is 2. 6 halves, which is 3. And 12 halves, which is 6. So this is all of them, but remember, it's plus or minus each one of these guys. So it's 1, 2, 3, 4, 5, 6, 7, 8. Plus or minus times 2. There's 16 possible zeros. It's 1, 2, 3, 4, 6, 12, 1/2, and 3 halves, plus or minus. Okay? Find the actual zeros and state their multiplicities. This is where the calculator comes in real handy at, because the calculator allows me to actually see these zeros are also known as the x-intercept. So I'm going to graph this polynomial. 2x to the 4th plus 6x cubed minus 6x squared. Oh, I kind of messed it up there. Let's try it again. 2x to the 4th over arrow on this new calculator plus 6x cubed over arrow minus 6x squared minus 22x minus 12. And I'm going to do a zoom standard negative 10 by 10 screen, and I'm looking for the zeros. Zeros are places that cross the x-axis. It looks like 1, 2, -3. My possible zeros, but I'm not sure based on the calculator, but it looks like my zeros are -3, -1, and because there's a little parabola there, that looks like a multiplicity 2, and a +2. Okay? So let's prove this by using our synthetic division on these particular zeros. So, and remember, when you use a 0 and you use synthetic division on it, your remainder should be equal to 0. Why we call them zeros here. So I'm going to take that -3, I believe that's my 0. I'm going to divide it into the coefficients of 2, 6, -6, 22, and -12. Okay? Skip a line, draw a line. And when I'm done, my remainder should be 0. If it's not, I screwed it. This guy's not a 0. So bring down your 2. Multiply -3 times 2 is -6. Add, I get 0. -3 times 0 is 0. Add, I get -6. -3 times -6 is a +18. Oops, watch my signs. That's a -22 there. All right, -22. So -22 plus 18 is going to be 4. -4. Watch your signs there. And -3 times -4 is a +12. And when I add, I get 0. And that's what I was expecting, because this thing looked like a 0 to me. But now we went from a 4th degree polynomial, because you knocked off a 0. Now this is constant x, x squared, x cubed. This is a cubic polynomial. I'm going to continue to knock it out by taking my next 0. I think -1 is a 0 on the quotient on this guy to see what else we're going to get. So I'm going to skip a line, draw a line, because I want to continue to try to reduce this guy down as much as possible. So bring down the 2, multiply, -1 times 2 is -2, add, you get -2. -1 times -2 is a +2, add, you get -4. Multiply -1 times -4 is a +4, and I did get a remainder of 0 for my last term. And what you're trying to get it down to is a quadratic. And because this is a 4th degree polynomial and reduced it by 2 zeros, this gives you an a constant, an x, and an x squared, which tells me the resultant polynomial, my quotient here, is now 2x squared minus 2x minus 4. It's a quadratic. So instead of using more synthetic division, I'm just going to set it equal to 0 and find my other two zeros. Here we go. I can factor out 2 out of the entire thing, so it'll be 2 times x squared minus x minus 2 equal to 0. That factors into, let's see, 2 times. See, x squared minus x minus 2 factors into x minus 2 times x plus 1 equal to 0. Set each factor that has an x in it. 2 does not. That's just a leading coefficient guy. So x minus 2 equals 0 and x plus 1 equals 0 means that x equals 2. Yep, there's a 0. And x equals -1, my other 0, which is a 0 again. So the zeros on this particular polynomial really were -3, -1, and 2, and I really grabbed those off the calculator. But so therefore, these are my c's. What are my factors? This is x minus c. So x minus -3 would be x plus 3. X minus -1, minus and minus makes it plus, that's x plus 1. And the last factor would be x minus 2. These are my factors. What are my multiplicities? Well, -3 went linear right through it, was a multiplicity of 1. However, the 0, -1 showed up twice, so it has a multiplicity of 2. And you can see by the graph on the calculator, it made a little parabola there, so I kind of knew that was a multiplicity 2. And the -3 and -1 linear cut right through it. When it cuts right through it, that's multiplicities of 1. So 2 only showed up as 1. So now we're going to factor the polynomial. So f of x is equal to x plus 3 raised to its multiplicity, which you don't have to write that, but I'm putting it for your benefit, 1. X plus 1, but that had a multiplicity 2, so you have to write the 2 up there. And x minus 2, and that had a multiplicity 1. The only thing left is you got to make sure the leading coefficient matches up. And what was the leading coefficient of my polynomial? Well, if you come back over here, the leading coefficient was 2, so it will continue to be the leading coefficient even after you factor it. So there's my polynomial. Okay, so we now have on this problem, we want to actually write these logarithms in terms of multiple variable, multiple logs of single variables, aka bust this thing up. So this is equal to log base 3 of 2 times x cubed times y to the 4th times z to the 5th divided by 3 w squared t cubed. Okay? Now remember, multiplication turns into addition, division turns into subtraction. So this is equal to the log base 3 of 2 plus the log base 3 of x cubed plus the log base 3 of y to the 4th plus the log base 3 of z to the 5th minus the log base 3 of 3 minus the log base 3 of w squared minus the log base 3 of t cubed. I know it's being multiplied down here, but you're looking locally. Globally, these guys are in the denominator. Denominator means divide, division turns into subtraction. Now to get my answer, powers get to go out front. So this thing would be equal to the log base 3 of 2. This 3 pops out front and would be plus 3 log base 3 of x. This 4 pops out front, so this would be plus 4 log base 3 of y. This 5 pops out front, so that is plus 5 log base 3 of z. This one's special. The log base 3 of the constant 3. Because the base and the exponent are the same, they'll cancel, and that's understood to be minus, sign stays there, that'll be a 1. This 2 pops out front, that'll be minus 2 log base 3 of w, and one more, minus 3 log base 3 of t. And that is my solution. I want to do the same thing to the problem down here. Now, natural log, again, whether it's the log base 3, common logs or natural logs, multiplication turns into addition and division turns into subtraction. So this would be equal to the natural log of x squared, plus y, plus, it's multiplication, the natural log of z to the 5th, minus, because this is division, the natural log of w to the 5th, minus, because the t squared is in the denominator. Denominator means divide, the natural log of t squared. Now powers get to go out front, but the reason why I put this one on there is because you got to remember you can't distribute logs. If you got a plus or minus inside a parenthesis on a log, you got to leave them alone. So this would be equal to the natural log of x squared plus y plus 5 natural log of z minus 5 natural log of w minus 2 natural log of t. All my powers went out in front. And so this is my solution. Now, classic with the Humpty Dumpty problems, you bust them up. Now we're going to put them back together again. But before you can combine logs, you got to make sure the coefficient in front of the logs are 1. So if you have numbers in front of the logs, you got to put them back where they came from. So this would be the log of x squared minus the log of z to the 4th plus the log of w to the half minus the log of y to the 4th plus the log of t cubed. All the powers went back. And now make it one big log of positive things go on the top, negative things go on the bottom. When you turn it, subtraction turns back into division, addition turns back into multiplication. So just pay attention to the signs. This is understood to be positive, so the x squared on this log goes out front. This is a minus, so the z to the 4th goes on the bottom. This is a plus, so the w to the 1/2 goes on top. This is a minus, so the y to the 4th goes on the bottom. This is a plus, so the t to the cube goes on top. And then the last thing that I would do for, so I would accept this answer, absolutely. Or, the only other thing is, remember, a half a power is a square root, so if they gave a multiple choice question on this, this would be the log of x squared times the square root of w times t cubed divided by z to the 4th times y to the 4th. So I'll take either one of those answers. And similarly, we'll do this one, but remember you can't distribute logs, but to combine logs, the numbers in front of the logs have to go back into the coefficient, back into the exponents. So this would be the log of x to the 5th plus the log of x squared minus 4 minus the log of z to the 1/2 minus the log of x plus 2. So combining logs, this is one big log of x to the 5th is positive, so it goes on top. The x squared minus 4 goes on top because it's positive. The minus, so the z to the 1/2 goes on the bottom. This is a minus, so the x plus 2 goes on the bottom. And honestly, I would accept this answer, but if they were doing the multiple choice question on this thing, you've got x squared minus 4 divided by x plus 2. And that x squared minus 4 actually factors into x plus 2, x minus 2. And you could actually cancel out those x plus 2. So the other answer that it actually on the multiple choice, what they would have put in, would have been log of x to the 5th times, this would have canceled, so it would have been x minus 2 over z to the 1/2, but 1/2 power is a square root, so that would have been a square root of z. And that's what it would look like cleaned up. So again, I personally would take either one of these guys, but on multiple choice, trying to prepare you for the final exam, that's what they would have done to you guys. Made you clean it up a little bit more when this answer wouldn't have been in your answer set. All right, and we'll finish up these last few problems here. So this top one, and again, I did a lot of these problems on the other video there. So I've got the log base 3 of 3x plus 2 equals 2. I'm going to, anytime I got a log, what I call a log type 1 equation, I'm going to actually what I call smile at it or use the smiley face definition. So to rewrite the log, I'm going to start with the base, 3, raised to the other side, squared. It equals what you're taking a log of, 3x plus 2. So this is pretty straightforward. 9 is equal to 3x plus 2. Subtract 2 from both sides, and that's going to give me 7 equals 3x. Divide by 3 on both sides, and that gives me x equals 7/3. Then don't forget, when it comes to logarithms, you've got to check your answer. But when I plug 7/3 in here, 7/3 times 3 is 7 plus 2 is 9. That's nice and positive. So this is the answer. X is equal to 7/3. I did this for you guys last time, but just remember the base on a natural log is understood to be e. So you do the same thing, smiley face definition. E cubed equals negative 5x plus 6. E cubed is just some crappy number on your calculator. Just leave them as e cubed. To solve for x, you got negative 5 plus 6. You would subtract 6 and then divide by negative 5. E cubed minus 6 divided by negative 5, or you can write it in decimal form on your calculator. This next one is a log type 1 equation. I got logs on one side equal to a number. When it comes to log type 1s, you want to combine logs. Notice the coefficient in front of the logs is 1, so addition turns back into multiplication. So this would be the log base 3 of x times x minus 24 equals 4. And then I would smile out to get rid of my log. 3 raised to the 4th power, 3 to the 4th, is equal to x times x minus 24. And so when I clean this up, 3 to the 4th on my calculator is 81. So I get 81 is equal to, here I would distribute my x's, and you should be very scared that, look, a quadratic showed up. I can hide anything into one of these log equations until you actually do the smiley face definition to see what it turns into. Being a quadratic, I'm going to set it equal to 0. But being that I created this quadratic, you know it's going to factor. So 0 is equal to x squared minus 24x minus 81. Factoring it. What times what is 81 that differs by 24? It's got to be 27 and 3. Because remember, 81 is 9 times 9, or 27 times 3. But my signs, because the middle is minus, one's a minus, one's a plus. That's the middle terms are minus. It's got to be a minus on that and a plus on the 3. So I'm going to set each factor. X minus 27 equal to 0, and x plus 3 equal to 0 gives me x equals 27 and x equals negative 3. However, when it comes to log equations, you've always got to go back and double check your answers. So double checking my answer on this one, I'm going to do this. Double checking it here, I'm going to double and plug it into the quote original equation to see if I'm taking a log of a negative number. I'm not checking to see if they're right, just checking to see if they're going to work. 27 is positive, 27 minus 24 is 3, that's positive, so x equals 27 works. That's the solution. However, negative 3 doesn't work. You can't take the log of a negative number, and negative 3 minus 24 is negative 27. This is an extraneous solution, so that doesn't work. So the only answer is x equals 27. I did this problem for you guys last time, but I actually put the answer in the wrong blank here. The answer goes up here. This was the natural log of function minus function here, and to combine it, that minus turns into division, equals natural log of 5. But this is a log type 2 equation, logs on both sides, so you can cancel log on both sides. You get this fraction equal to 5, cross multiply or multiply by your denominator, distribute, and you end up solving for x, you get negative 33/5. The problem with negative 33/5 is when you plug it back into this thing here, the original problem, you end up taking the log of negative numbers, which means the answer does not exist. Okay? Let's try this one. Log, understood to be base 10 of 4x squared minus plus 3x minus 9 minus log of x equals the log of 4. First thing I want to do is get rid of my coefficients, okay? Because I've got a number in front of the log, it's got to go back in the exponent so I can combine logs. So this is log of 4x squared plus 3x minus 9 minus the log of x squared equals the log of 4. Subtraction turns into division, so this would be the log of 4x squared plus 3x minus 9 over x squared equals the log of 4. Again, I got one of these log type 2 equations. Log on one side equals log on the other. So you can just get rid of the logs. Officially, you can just cancel the logs, but officially you're raising 10 because there's a base 10 logs here to both sides. But the end logs end up canceling. This was a nice problem because you end up getting this. You get 4x squared plus 3x minus 9 over x squared equals 4 when you cancel the logs. I multiply both sides by x squared, so it ends up canceling over here on the left and times x squared on the right. So now I've got 4x squared plus 3x minus 9 equals 4x squared, a quadratic, but not really, because you would subtract 4x squared because you always set quadratics equal to 0, and they actually cancel on both sides, leaving you with 3x minus 9 equal to 0, and adding 9, you get 3x equals 9, divided by 3, 9 divided by 3 is x equals 3. And then I go back and double check it, and when I plug it into this thing, you're taking a log of nice positive numbers. So the answer to this problem is x equals 3. That was my solution there. On this one, I kind of stopped short trying to help folks out here, but this is an exponential equation where I have 4 raised to 2x plus 3 equals 16 raised to negative x plus 15. But this was special on the exponents in the fact that I can write both of my equations in terms of the same base, because 16 is actually 4 squared. So I got 4 raised to 2x plus 3 equals 4 squared raised to the negative x plus 15. And a power raised to another power. Classic exponential properties. Power to a power you multiply. So I got 4 raised to 2x plus 3 equals 4 raised to 2 times negative x plus 15. And if the bases are equal, that implies the exponents are equal. So I have 2x plus 3 equals 2 times negative x plus 15. So that gives me 2x plus 3 is equal to negative 2x plus 30. Add 2x to both sides. That's going to give me 4x plus 3. This cancels, equals 30. And then I'm going to subtract 3 from both sides, giving me 4x equals 27. And then I'm going to divide by 4 on both sides. So x is equal to 27 over 4. And this one, I have classic, you see this one got a lot. 500 equals times e raised to 3x plus 2 equals 1500. A classic exponential e, where the variable is in the exponent of an e. So the first thing I got to do is I got to divide by 500. This cancels and allows me to e raised to the 3x plus 2 to be equal to 15,000 divided by 500. And just to show you on my calculator, 15,000 divided by 500 is 30. There it is. This thing equals 30. Now I want to get rid of the e, so I'm going to hit the natural log of both sides. Natural log and e's cancel. So this is 3x plus 2 equals the natural log of 30. Now I'm solving for x, so I would subtract 2 from both sides. These are not like terms as natural log of 30, just a crappy number, so leave them alone. So this is 3x equals natural log of 30 minus 2, and then I would divide by 3 on both sides, giving me my answer. X is equal to natural log of 30 minus 2 all over 3. Or for you guys that want to put it on your calculator and get the decimal, that's perfectly fine. That would be 0.4670657939, and I would accept either one of those. And again, we did this problem last time with the 8 times 3 raised to the 2x plus 4. The first thing I had to do was divide by 8, and then I used a common log of both sides, and then kind of get my answer and went for a decimal on it. So it's a very similar kind of problem. If you invested $48,000 at 6% interest for 7 years, find the amount in the account if the money was invested compounded annually, compounded monthly, and compounded continuously. Again, just trying to drum the formulas on for you. A equals P times 1 plus R over N raised to the NT, and A equals PEPRT PERT. Okay? So in this problem, I have the principal is $48,000. My interest rate is 6%, which is 0.06, and my time is 7 years. Okay? If we're compounding annually, N equals 1. So this is regular compounding, so I'm using this formula here. So plug it in. A is equal to 48,000 times 1 plus 0.06 divided by 1 raised to the 1 times 7. And now you just basically put this on your calculator. Let me clear this out so you guys can see this. So this is 48,000 times parentheses 1 plus 0.06 officially divided by 1. Don't have to do that. Close parentheses raised to the 1 times 7, or just 7. And I end up getting how much money? Amount would be $72,174.25. And on my test, obviously you want to round money numbers off to the nearest penny. But the only difference here is if I compounded monthly, that would be 12 times a year. So now we're changing it to n equals 12. So your amount in the account would be 48,000 times 1 plus 0.06 divided by 12 raised to the 12 times 7. So typing that in on my calculator, I end up getting this. 48,000 times 1 plus 0.06 divided by 12 raised to the 12 times 7. Now, if you got the old style calculators that brought it down, you have to put parentheses around your exponent. And then the amount in the account would be $72,977.74 to the nearest penny. And look, the difference between compounding annually versus compounding monthly is over 7 years is $800. But granted, we're also talking about $48,000. And the last one is compounded continuously, so that's that special PERT formula, A equals PE to the RT. So that would be $48,000 times E to the 0.06 is your interest rate times 7, year 7. So that would be 48,000 times E raised to the 0.06 times 7, which is, the amount is equal to $73,054.15. Okay, we got radioactive decay problem. So we know we're using the formula P of T equals P naught e to the KT. This is the form on those exponential half growth problems and half-life problems and the like, and this is a half-life problem. So you have the initial amount, 200 grams, so that's my P of 0. That's 200 grams. And it's extremely radioactive, and its half-life is 20 days. Remember the definition of half-life. The amount of time it takes for half the substance to be cut in half. We want to first find the decay rate. So I'm going to use this half-life. So my time is equal to 20 days, which means I start out with 200 grams, and the P of T, the amount after the 20 days, would be 100 grams because it literally gets cut in half. So plugging all that into this formula, I get 100 is equal to 200 e to the k times 20 for 20 days. Solving for k, I first want to divide both sides by 200, and what a surprise on the half-life, 1/2 shows up, 100 divided by 200 is a half, equals e to the 20k. Then I'm going to take the natural log of both sides, and the natural log and e cancels, leaving me with the natural log of 1/2 equals 20k, and then I divide by 20. And I get k to be equal to, and I'll use my calculator again, big calculator problems, natural log of 1/2 divided by 20. And it's a decay problem, so I'm expecting a negative exponent, negative 0.03657359. Honestly, if you take it out to 4 or 5 decimal places, I'd be happy and give you full credit for that. But your k value is equal to negative 0.0346573559. So now we're supposed to find the formula for the amount of kryptonite, which is the classic formula P of T equals P naught e to the KT. So that's just P of T equals, the P naught was 200, e to the K was this negative 0.034657359 T. And so that's just the modeling equation. How much kryptonite will we have after 30 days? So this is P of time equals 30. This would be 200 e to the negative 0.034657359 times 30 and the exponent there, which means it's nothing but an exponential equation. So this would be, just plug it in the calculator, 200 e raised to the negative 0.03 4657359 times 30 days, which gives me the amount is P of 30 is equal to 70.71067818. And you guys don't have to take it out semi-decimal places. I'm just trying to show you if you're doing it on a calculator, this is what you would get. And that would be grams of kryptonite. And then this one, how long would it take for you to only have 10 grams of kryptonite? All right, 10 grams. So that would be my P of T would be 10. So I would have the equation up here. 10 is equal to 200 e to the k negative 0.03 4657359 times t. How long? Solve for t. If I'm solving for t, I'd first divide by 200 on both sides. This cancels 10 divided by 200. That's just pretty much 1 over 20. Equals e to the negative 0.03 465,359 t. Then I would take the natural log of both sides. So my natural log and these cancel. And then I would divide by negative 0.03 465,359 on both sides. Negative 0.03 465,7359. Get all my decimals there. And that cancels, so I get t is equal to, I'm doing it on my calculator, 86.4385,619 days. And of course, if you guys round it off to like 2 decimal places, yeah, that's perfectly fine. So after 86 days, you're only down to 10 grams of kryptonite. This again is another one of these calculator problems here. All I wanted you to do was 4 decimal places. What is the log of 125? That's understood to be base 10, getting used to your calculator. Log of 125. Whoops, it'll plus by accident there. Log of 125 is 2.0969, 4 decimal places. What's the natural log of 58.3? Natural log of 58.3 is 4.0656. This one requires the change of base formula, log base 8 of 218. But remember your log of change of base formula, this will be the log, I'm going to use the common log of the original number, 218, and you divide by the log of the original base. This is why they really only have 2 log buttons on your calculator. And if you go in through the catalog and get the special log button, you can do it that way, and that's fine. But I'm trying to show you the change of base formula. The log of 218 divided by the log of 8, which is equal to 2.5894, rounding it off to 4 decimal places. And the last chapter 8.1 material, and we talked about these, just good practice on solving system of equations. I got one of each different kind. Substitution method and elimination method. First, the substitution method. Substitution, I got 2 equations. I got y equals 3x plus 35 and 4x minus 2y equals negative 20. Okay, solving for this thing here. Since I already got y equals in terms of the other equation, substitution is almost the obvious choice here. So I'm going to take my second equation, which is 4x plus 2y, and I'm going to replace that y, substitution, with the 3x plus 35, and set it equal to negative 20. I'm going to distribute 4x plus 6x plus, and 2 times 35 is 70, equals negative 20. 4x plus 6x is combined like terms. 10x plus 70 equals negative 20. I would subtract 70 from both sides. This is going to give me 10x is equal to negative 20 minus 70 is negative 90. This comes out to be nice, so I divide by 10 on both sides, and x is equal to negative 9. But you have to go back and get the y coordinate, because with a system of equations, we want to see both variables, x and y. But you go back to the easier equation that solves for y, as y is equal to 3x plus 35. Then y equals 3 times negative 9 plus 35. Y equals 3 times negative 9 is negative 27 plus 35. Negative 27 plus 35 is 8. So I get y equals 8. And traditionally, the way we like to write our answers is ordered pair format on the system of equations. X, y, x was negative 9, y was 8. This next one is I wanted you to use the elimination method because the variables literally line up. So I have the equation x plus 5y equals negative 18 and 2x plus y equals 36. I want to use the elimination method. So I want to decide which variable I want to eliminate. I think the x will be the easiest number, so I'm going to take, but remember to eliminate, I want to multiply by a particular constant, and I'll make sure it has the opposite sign. Since this is a positive 2x, I'm going to take the first equation and multiply it by negative 2, and I'm going to distribute it to all the terms. This is going to give me negative 2x, negative 2 times 5 is going to be a minus 10y equals a negative 2 times a negative 18 is a positive 36. The bottom equation stayed the same, 2x plus y equals 36. And then I'm going to add the two equations together, and you're going to eliminate the equal but opposite coefficients. Negative 2x plus 2x is 0x, which is 0. Minus 10y plus officially 1y is minus 9y equals 36 plus 36 is 72. I'm going to divide by negative 9 on both sides. That's easy math. Y is equal to 72 divided by a negative 9. That'll be negative. 72 divided by 9 is 8. So the answer is y is negative 8. But now I got to go back and figure out what the x is going to be equal to. So I can use either one of the two original equations. I'm going to use the top equation. So here we go. I got x plus 5y equals negative 18. X plus 5 times negative 8 equals negative 18. 5 times negative 8 is negative 40, so x minus 40 equals negative 18. Add 40 to both sides, and I get x is equal to, and just to make sure you got to get it right, clear it out, negative 18 plus 40 is 22. I got x is 22. Therefore, I'm going to write my answer as, in ordered pair format, xy is going to be 22 comma negative 8. And we did the last one actually in class because I wanted you guys to show what happens when you have all the variables eliminated. If you use the elimination method and you're substituting or eliminating and you combine like terms and all the variables eliminate. In this problem I have 4x minus 2y equals 9, negative 12x plus 6y equals negative 18. I'm using the elimination method, so I'm going to multiply to eliminate the x's, multiply the top equation by 3, and when I do, I get 3 times 4x, which is 12x, 3 times minus 2y, which is minus 6y, equals 9 times 3, which is 27. The bottom equation is negative 12x plus 6y equals negative 18, and when I add them together, all my variables end up canceling. So negative 12x minus 12x is 0, negative 6y plus 6y is equal to 0, but 27 minus 18 is 9. And what's left over is false. I got 0 because all my variables canceled equals 9. When everything cancels, you got a 50-50 shot. The answer is either no solution or all real numbers. But it depends on what's left. If it's a false statement, like in this example, 0 equals 9, that's false. The answer is does not exist. If you did this and you got 0 equals 0, which is a true statement, then the answer would have been all real numbers. So this is your extreme case of that inconsistent answers, okay? And so no solutions or all real numbers. Now this homework set has been incredibly long, and I did that on purpose because the test is going, if you study this thing real good and look at all the different stuff we did, because test 3 we covered a lot of material, but I'm telling you, the test is going to be a lot shorter than this, obviously, and I'm going to like I said, it's going to, but if you can do this, you should ace my test. So I try to do an over example on the homework set to get you guys to practice this stuff to make sure that hopefully you'll do very well on the test. So I'll see you guys on Monday, and good luck.